Okay, moving to multiplication, same thing. We do have a procedural way that we teach multiplication or an algorithm of sorts, okay? And I always try to start out with two-digit multiplication here because obviously one-digit multiplication is its own easy enough ball of wax to show students. If we have 3 groups of 4 or 5 groups of 10, that's easy to illustrate. But what happens once we get into two-digit? So let's say I have 15 times 3. Okay. If I wanted to put this in context, I might have a conceptual or a contextual problem that says Jason has 3 packages of pencils, each with 15 pencils. How many pencils does he have in total? Okay, so context means I have some meaning to the numbers. Without context means I just have a calculation. But now, how can I show this conceptually? If you were taught previously, let's actually just make this 13. Okay, two-digit multiplication. Maybe Jason has 13 packages of pencils, each with 15 pencils. How many will he have in total in context? In terms of concept, okay, if you were to ask many students who've been taught how to do this procedurally, okay, let's work through what that procedure would be. Well, most of them would start out with 3 times 5 is 15, carry the 1, 3 times 1 is 3 plus 1 is 4. Then they would say, okay, now we have to scoot over. They have no idea why, but they would say 1 times 5 is 5, 1 times 1 is 1, and then we add. Now, why on earth do we add when we're trying to multiply? Nobody knows that either. But if we have 13 times 15, altogether we have a product of 195. Okay. Now, like I said, I will ask many students, why did you scoot over here? I don't know. That's what my teacher told me to do. Why did you add these? We're multiplying. Why did you add? I don't know. That's what my teacher told me to do. So that's how you know when nobody can answer those questions. That's how you know you've learned procedurally, okay, not conceptually. Now, one of the things I do with elementary teachers is I use a array method with base 10 blocks. This gets a little bit more complicated, but remember, you're also going to be having older students that are performing these calculations, not necessarily the same as your younger students. I'm going to take this off and I'm going to try to draw that out. Okay, so now what would I do? Well, first of all, I would split this, okay, and I would represent each one of my factors, 13 and 15, in base 10 blocks. So I'm going to start with 15 up here. So I know I would have a long, and then I would have 1, 2, 3, 4, 5 individuals. Okay, so for 13, I'm of course going to have a long and 1, 2, 3 individuals. Okay, and now what I'm going to do is I'm going to go across and I'm going to multiply these. So I want to think about their worth. Obviously, a long is 10, right? So if we have 10 times 10, of course, that's going to be 100. Okay, now how would we represent 100? We wouldn't use a long. There we would represent a flat. Okay, so now 10 times 1, that would be 10, which is a long. And of course, that's going to be the same all across. Okay, now let's continue to do that. Now I have individual ones times everything. So 1 times 10, that's going to be a long. 1 times 1, single, all the way across. Okay, now since all of these are singles, we know we're going to get the same thing all the way across. Okay, now once we've done that, now we have to start thinking, oh, what do we have? Okay, what do we have represented here? All right, I always start with my singles first. Now, why do I do that? Because if I have to trade up, remember we want to express our answer in the fewest blocks possible. So if I have to trade up, I want to do that from the smallest up to the largest. That way I don't have to go back and recount. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 singles here. Okay, so what's going to happen? If I have 15 singles, then I'm going to trade 10 of them for a long. And then I'm going to have 5 left. Okay, so if I'm thinking about writing my answer in the ones place, I know I have 5. Okay, because that handles those 5. So now let's go and let's count our longs. It's going to be our tens place. We have 1, 2, 3, 4, 5, 6, 7, 8, and then this one, now that's my tens place, gives me 9. Okay, my flats going to give me 100, so I only have one of those. So there's my answer of 195 by showing this multiplication and breaking it down. I also think in order to see, of course, this answers the question of why do we add? Okay, why did we add those two things together? Well, we had to combine all of these results. Okay, we're combining that together in order to give us our total product. Okay, that answers one of the questions. But the other question I asked you was when we were doing this calculation, why, when we got to multiplying by the 1, why did we have to scoot over? Okay, and that can really be explained through this array as well, but we have to think about it really well. Okay, think about what you're doing. When we say 3 times 5, what are we really doing? 3 ones times 5 ones, and that's 15. Okay, then we're also doing 3 ones times 1 10. Okay, that 1, because it's in that position, is a 10. So this isn't 3 times 1. Essentially, this is 3 times 10. Okay, so that's why I have 30. Okay, now remember, I carried that 1 there, or carried in quotation marks. Okay, I traded up that 1 from this 15 singles. I traded up 10 of those, which gave me another 1 above here, which means I have, this just gives me 30. We'll just leave it like that for now on, and we'll combine in the end. All right, so now if we were doing that standard algorithm or that process, we know we would have 45 here. What do you notice? That is the exact sum we would get from combining these answers of when I took those 3 ones times 5 ones and 3 ones times 110. Okay, so now think about this. Why do I scoot over in this next step? When I go to multiplying by the 1, why must I scoot over? Think about the calculation we're actually doing. That 1, because of its position, that's a 10. Okay, so I'm not saying 1 times 5. I'm essentially saying 10 times 5 ones, which is 50. Okay, it's not 5. If we were to put that here, we would be representing 5 individuals. Whereas we're going to scoot over, we put it here, we're indicating the tens place. This is why a lot of people will use 0 here, or they'll just mark it out, whatever. We have no singles because we're automatically multiplying by 10. At the minimum, we're going to have, when we start multiplying by this second digit to the left, is going to be worth at least 10, because that 1 is not a single, it's a 10 by its place value. Okay, now keep on going here. If we were doing this by standard procedure, 1 times 5 is 5, 1 times 1 is 1. Okay, so think about that next calculation. This 1, I've already did 110 times 5 ones. Now I'm doing 110 times this 1, which is also a 10. Okay, so there's my 100. So look at this second step, 150. That is what I get when I combine the multiplication of this place value times each one of those place values. Sometimes you hear this called partial products in multiplication. When we add all of these up, we combine all of the results of these multiplications. Okay, that's going to give us our total product. Basically, what we've done is we've multiplied piece by piece here. And when we keep track of the place value of what we're multiplying, that's what gives meaning to why we scoot over in the second, when we're multiplying by the second digit, and also why we combine these and why we add. I had a lot of students, once they draw these out, they will say, oh, that makes so much more sense in how I multiply. And it makes sense in terms of why this process we've all been taught works. In essence, this process is doing the same thing we did when we drew that out up here in an array, okay? But after we've done this a few times, and then we've followed through by showing these calculations a few times, it starts to make sense what's happening here. And you no longer need to show that every single time to have a conceptual understanding of what is going on. If nothing else, these procedures are a shortcut to illustrate all of the calculations that we're doing for multiplication here. So I hope that helps a little bit. Let's see if we can draw another one and try to work that out. So I'm going to get a blank document here, back to draw. And make sure that I am using the correct color. Okay, so let's say 12 times 21. Okay, and we're not even going to go to the procedure right now. We're just going to go ahead and start drawing that out. So remember, what would we do? I would create a separation. I'm going to put one of the values on the top and then one down the side. So 12, that would be one long and two singles. Okay. Down the side, I have 21. So I'm going to have two longs and one single. Okay. And then I'm going to go row by row. I have a long times a long. So that's 10 times 10. If you're ever confused about that, think about their worth. 10 times 10. It's 100. That's a flat. Same thing here. Okay. I have a 10 times a 1, which is a 10. 10 times a 1, which is a 10. And the same thing here. Okay. When I go down to complete the last matchup, I have a 1 individual 1 times 10. So that's a long. It's 10. 1 times 1. 1 times 1. Okay, so let's think about what we've got all together. I've only got 2 individual blocks, so that means my 2 is going to go in the ones place. Then I'm going to count my longs, 1, 2, 3, 4, 5. And then 2 flats. So my answer should be 252. Let's go down, see if we can work that out by multiplication here, okay? I had 12 times 21, so 12 times 21. Okay, I have 1 times 2 ones. So there's my 2. And then I have 1 here times 110. That's my 10. Together, those are 12, right? So that's why if I were to come over here and follow my procedure, I would have 1 times 2 is 2, 1 times 1 is 1. I would have 12. That comes from that combination of calculations. A 1 times 2 ones and a 1 times a 10. Okay, so let's come back now. We got to scoot over. Why? Because this 2 no longer represents 2 ones. That's worth 20 because of its place value. So I have 20 times 2. That's 40. And then I have 20 times 10, okay, which is 200. Okay, so if I were to come here and do that through procedure, 2 times 2 is 4. 2 times 1 is 2. And then I would add, okay, so 2, 5, 2. What would I get when I summed all these together? 252, the same as what I've gotten here from this array.